Hello, everybody. Welcome to the fourth workshop. This first workshop, we're going to be looking at. Hopefully, they can hear. We'll find out. Yay! So there's that. A little bit of an impromptu. This is the first time we're sort of set up a new system because we have a special guest. I'll get to that in a second. And yeah, we're going to be focusing on optimizing space for Mona. We have a very long list of techniques to do that. So we'll be looking at that. Now, speaking of a special guest, we have Joshua, who everyone has seen in the Discord. We have him on board. There we go. You are now unmuted. You're allowed to say whatever you like. Yay. And yeah, we have quite a bit to get into, so let's jump in, shall we? There we go. All right, so basically, actually, I should get the latest template. I'm gonna steal that. Oh, it is. Why is that? Oh no. There we go. Okay, there you go. Actually, okay. Interesting. Good to know. All right. Mona Gallery. No, we want the docs. Get the latest. So, Joshua, while I get the template up and running, feel free to introduce yourself and describe what you're going to talk about today. Huh? But you're... Yeah. Hang on. Okay. You're gonna have to do that all over again. Sorry. Okay, hang on. Let's do this one. Okay, now try.
Let's see if it works.
Can someone
got it.
Confirm?
Listening seems good to go. Okay, cool. Yeah, sorry, I was just trying to telepathically kind of beam everything to you guys. So, no. So, yeah. So I'm Josh. I've been part of the Mona community for about a month or so. Just been trying to help out, fit in where I can. I was going to participate in the build-a-thon. Ended up focusing a lot more of my efforts on trying to help out with everyone. So, but I've been using Unity for about probably close to 6 or 7 years or so. So I have a decent amount of experience, and just hoping to share that with as many people as possible.
Cool. Excellent. Yeah, I've noticed in the
Echo.
Me? You? Echo?
I don't know. Echo, apparently. Echo.
You sure it's not you, Matt? We're fine. Everything's going through my headphones. I'm pretty sure. Yeah. It's Matt's fault.
I don't know. Sometimes it echoes in the space between my ears. So.
Yes, it is 100% just you. Okay. So that's the template ready. Let's jump in, I guess. Eddie, yeah, let's get into it. Okay, so we have a long list of things to get through. A lot of this will basically be focusing on optimization either for file size or performance or both. And basically we want to get as high a frame rate as possible. And this will be much more important when VR kicks in, because basically you need a minimum of 90 frames a second for a good experience, and 80 as a, like, I'll probably get a little bit sick, but I really like the space, so I'll keep hanging here. So yeah, when we want to get into the VR space, the whole experience of frames per second is much more important. So we need to figure out ways to do that.
Especially considering in virtual reality, you also have to remember that everything that's being rendered is double, one for eye. That's also something to consider.
Yeah, they do have some tech to speed that up. They've done some interesting stuff with like how they've done that. I have even no idea how they've magically made half the stuff they've done to work with VR. But yes, so there's a lot of that going on. So let's start with crunch compression. This one is a big one for file size more than anything else. So basically, let's have a look. We have some textures here we can work with. Yeah, that should be enough detail. So say, for example, when you go to your textures, so they are here, for example, we have this option here. Now, of course, you can adjust all of these per texture, and that will be what is built into the playground files, for example. So that's much smaller. That said, the original files, so if this was like an 8K texture, and then I put it down to 512 here, the 8K will be built into the mintable file, I believe. And that's why some mintable files are like 2.8 gig, but the playground files are like 100. So make sure that once you figure out what texture size you have in your object, basically get these down to the actual file size that you want to go if you want to optimize your mintable files as well. So yeah, so basically adjust these as you need to. And once again, you can see what they look like very easily by just hitting apply. And then keep going up until, still a bit fuzzy, until you sort of are comfortable. Because that's not too bad, for example. And that's only 256. But say, for example, that difference there was very small. So perhaps I could probably get away with that on a less important area. This applies to all textures, for example. So once you have your world how you see it, and you really want to clean up your textures, start doing this with every single texture. It will save a lot of time because every size up is 4 times the file size, I think, which gets to a bit of a jump for sure. The next thing you can use is crunch compression. This will save a lot. So, for example, that's 1 point. If I turn that off, for example, that will go to that. Let's pump it down to that. Yeah, why? That usually updates. What's going on?
Is it not updating the size?
No, it's still 1.3 meg at crunch compression 0 quality. Okay, that's weird. Maybe because it was on and now it's off. Okay, so usually in a perfect world, using crunch compression will reduce the file size quite a lot. And once again, you can adjust the level, apply that, and you can see the difference. I'm wondering if these are crunched already, so it doesn't actually make any difference. But yes, crunch compression is super, super useful. Small note though, someone did have issues with, what was it? Using crunch compression and emissive using bakery. So
that makes sense.
That was a bit of a complication in regards to using crunch compression. Light maps and bakery, it would crash, I think it was. So what I would recommend do to get around that is do all your baking without crunch compression, and before like building or melting, like the final, then adjust and add all your crunch compression onto the files. That would probably get around that problem, but then you would have to undo that if you wanted to update it. So make sure it's all done and dusted, happy, mintable, if you will, and then add all your crunch compression, and off away you go. So yeah, crunch compression, change max size, apply, and once you know your file sizes, re-import the final file size to your actual project folder, and then all your file sizes will be much, much smaller. So that's that. Joshua, your first one.
Okay, how about we grab my list?
Yeah.
How about, I guess we can talk about LODs first. That's
Sure.
probably the small section. Okay, do you have that file I sent?
I did, but then it went away. So give me a second. You might freeze. There you go. You do freeze when Discord is up. That's why that happens.
Wait, it's open?
No, I haven't got it yet. Hang on.
Wait.
No.
So my video freezes when Discord is open?
Sorry. The pop out. When I've got the pop out.
Oh.
Yeah.
That's what you're saying. Okay.
So if I reduce that and then click on that, then you should be fine. Cool. The wonders of technology. All right. So I have a package from Joshua called Tire.
It's pretty straightforward.
Yeah. I'll be the judge of that.
Okay, so LODs, LOD stands for level of detail. Essentially, it is determining how much detail should be rendered at a certain distance. So obviously, the farther away your camera is from an object, the less detail you can see on that object, but by default, you will still be drawing the same number of vertices when it is unnecessary to do that. So what level of detail systems can do is reduce the detail of a mesh the farther away you are from it. The way it would work is you would create multiple versions of your mesh in your 3D software, and each version having a slightly reduced quality each time. And then Unity can use those to determine the quality to use depending on how far you are from it. So in this example, I just created like a tire here, and as you get farther away from it, it will use a higher LOD level, which will essentially be using the lower and lower poly count mesh as you get farther away from it. Another thing that is cool with that is in your 3D software, if you create your meshes following a specific naming convention, Unity will actually automatically use the files that you named to create a LOD group. So normally you would have to add this LOD group component that's on like that, the main mesh, and then it would kind of use the children of that to create the different LODs. But here, using the naming scheme, you just put an underscore and then LOD starting from 0 going up as you decrease your detail. Unity will actually, when you import it, automatically create an LOD group for you on the parent mesh. So that is something that's kind of convenient. And yeah, as you see, when you click through it, it'll show you what they all look like. One thing that I will say with that is when you use LODs, it's important to determine if you actually need them. Like if you have a mesh that's always going to be really close to the camera, you probably don't need to create LODs, or maybe you can create fewer LOD levels. But if you have something that's going to be close or far, that's when it would be really great to have those different LOD levels. But if you have something that's always far away, it's probably good to just make it lower detail in the first place and not bother with LODs, because the more versions of your mesh that you add, the more disk space you use and the more memory you're using. So that's kind of how you want to determine whether to use a level of detail in your scene. Anything to add?
No, That's cool. I've never used LODs. So
I haven't
useful to me. Yeah, although thinking about it, the spaces I've used, yeah, I probably could have used them a couple of times. But yeah, good for hero objects. So if you have something with like really high polygon, but as soon as it gets away, you can sort of cut it out. Because a lot of hero objects will use normal maps and stuff, and the silhouette is most important. And when you're at a distance, the silhouette like doesn't need that much detail. So you can definitely cut down on a lot of that sort of stuff for that sort of effect. So I need more hero subjects now. All right. Okay, so that's LODs. Next up, I was going to do light probes, but like we've definitely covered that in previous workshops. The main thing with light probes is purely when light changes in. Well, let's do a super quick example. So let's put that up there. Put that under space where it should be. Wink, wink, nudge, nudge. Create an empty light probe example, and then add light probes. So do light probe group. Show gizmos. Right. So basically, each light probe, each one of these little dots is an approximation of all of the light that is in that physical location, for example. So in this template space, for example, the light doesn't change much. So we could probably actually have these like way out, and that would be accurate in regards to how much light. But say, for example, if you have a wall or corridor situation where one hall is really bright and one hall is really dark, then you would actually need to create a lot more. So say, for example, you can select, let's call them probes, Control D will duplicate them, or Control C, Control V will copy them, and that allows you to sort of create as much as you want. So D is actually faster. I should use that more often. So basically, when an object is... Turn that off there. When an object is within... Sometimes it works, sometimes it doesn't, where like, you'll have an object and it'll have the light probe sort of show where it is. I don't know how to turn that off or on. It's really annoying. But so this light probe, for example, would be a collection of sort of those eight probes there to light this. Now, this works for dynamic objects, so there's some light that gets applied to the character, for example, or any elevators that are not light mapped will fit into the space more. Without light probes, it feels like they're like a bit of a cutout because the lighting doesn't affect, like the space lighting doesn't affect that real-time or dynamic object. So light probes are pretty important. Pretty performant because there's very little information in each light probe. Like it's literally just a piece of color. There it is. There, that. So keep that in mind. But for the most part, it's just most of these probes are in heavy light changing areas, and then big gaps for very same lit areas, for example. So yeah, that's that. Hey, Fractalians, Karuna, Matt, Alv, anyone else that I'm missing? Not Kite, how's it going? Yeah, just say hello to everybody. All right, so that is light probes, basically. Pretty quick, but very important to get a nice feel for your space. All right, Joshua, what's next?
We'll go with draw calls. I think we'll lose occlusion to the end.
Okay.
Okay. So draw calls are a bit more of an abstract concept, but essentially when Unity wants to draw something on your screen, it will it'll provide the graphics card with draw calls, which essentially tell it what to draw, where, and how. So draw calls are relatively cheap, but what happens between draw calls is state changes. So there's information that has to be passed from the CPU to the GPU. and that information changes and needs to be recalculated between draw calls, which is expensive. So there are a couple ways to kind of reduce how much that affects your performance. You can try and reduce how what information is changing. So like you're reducing the amount of information that has to change between draw calls, or just reducing the number of draw calls, which reduces the number of state changes. So reducing the number of draw calls is usually the go-to method for that. And there's a few ways to do it. So I guess we'll go ahead and talk about GPU instancing first. So GPU instancing is something that you'll enable on a material, which essentially allows objects with the same material to be put together and rendered in the same batch. Because what happens is all of your meshes are put into batches, which are then drawn in a single draw call. So each batch will be one draw call. So when you enable GPU instancing on a material, that will allow any object that has that material to be batched together, which will reduce the number of draw calls because you won't have to have a draw call per object. One thing to mention with that is sometimes there can be a bit of overhead. So usually it's actually only going to be worth it if you have larger meshes. So if you have a mesh that has more than 256 vertices, is usually a good limit, that's when you'll want to enable GPU instancing. And as you saw with what Matt did, you just enable it under the advanced options. Not every material supports it, but the standard shaders do. Okay. The next method is
quick question. Quick question.
Yes, go for it.
So if I had those 4 tires, without GPU instancing, it would treat each one as a separate one?
Most likely, yes.
Right. Okay. Interesting.
Now, in that case, it might. Well, I think it'll be a performance benefit because I think in total there'll be more than 256 vertices.
Right.
I have to double check if it's 256 per mesh or in total.
Right.
I have to check on that.
So it's more a case of just like, so by better safe than sorry at this point kind of thing.
Yeah.
Okay.
Just don't use it on really small things because
right.
You'll be introducing extra overhead.
Right.
Okay. The next method of reducing draw calls is called batching. So this is kind of how I mentioned that Unity sticks all of your models into batches. Batching is a way to take separate models and put them into one batch. So instead of doing a draw call per mesh, you're doing a draw call once for both meshes. Basically, you're trying to combine similar meshes or meshes that are close, essentially, or actually more accurately, similar vertices into something that can be rendered in a single draw call. So there are 2 main types. So I'll talk about static batching first. Static batching is kind of what it says. It's for static objects. So you can combine meshes together, Unity will combine the meshes together for you. So let me double check where that is enabled, because it is slipping from my memory at this point.
Is that different from the normal static at the top right?
Actually, if you click the drop down next to static in the top right, you can enable just batching static. So you don't have to have it be static for everything. You could just have it be static for batching only. Okay. If you disabled everything else. So if you didn't want it to be light mapped, or if you didn't want it to be enabled for occlusion calling, which we'll get into, you could just enable it for batching static, and it would just be batched along with everything else. But by default, when you click the check mark for static, it would just mark all of those, so it would be batched static.
Right.
So yeah, that's essentially how you run it, is or enable it, is just to make your object static. There is a setting in the project settings, but that is handled by Mona. Okay, so let me see. So static batching has a bit of a memory footprint, so you don't want to use it for too many things. Like the example that the Unity docs gives is if you have a forest, you don't want to enable static batching for all of those trees, because that will create kind of separate instances of all of those trees in your memory. So you're kind of like duplicating all of those meshes, because it will store the individual meshes in memory, and it will store the new batched mesh because it's going to combine all of the meshes into a single one. So you don't want to do it for too many objects like that.
So with that one, you would, if you wanted to put those trees into the light map, you would make it static, but not on batching static. Is that like contribute
yes, that
GI?
would probably be a good idea.
Right.
Mm-hmm.
So you would turn that off, and then basically contribute GI would be the main one for baking. Is that correct? And reflection probe. Okay.
Yep. Exactly.
Cool. Interesting.
One thing to mention with batches is they can only have up to 64,000 vertices. So if you have a lot of meshes, and you try to static batch them all together, it's probably going to end up splitting them into 2 batches.
Okay.
So that is something to keep in mind. That's why it's best kept for kind of smaller sets of objects.
Cool.
Okay. So the next one is dynamic batching. That is given the name for dynamic objects. It's pretty much the same thing, except you don't have to like check a box or anything. I think it, as long as it's enabled in the project settings, it should do it automatically for you. I believe, if I remember correctly. But dynamic batching is good for small meshes. I think, if I remember correctly, you should be able to disable that somewhere. Let me double check. Oh yeah, I think that's like a general setting. So I actually don't know for sure if Mona supports this. I have to check with him to see if it's actually supported. But dynamic batching exists. So it's best used for smaller meshes, because there is a CPU overhead for it. Essentially, what it's doing is it's transforming some vertices together on the CPU, which is, it can be slower if you have too many. So usually that's it only actually works up to 900 vertex attributes, or if you're not really sure about what those are, the general rule of thumb is about 300 vertices. So if you have a mesh that's above 300 vertices, it's not going to be dynamically batched. And it also does not work with multipass shaders. So for instance, the standard shader in Unity is multipass because I believe there's a second pass for lighting, if I remember correctly. So it will not be fully dynamically batched. Like, it might be dynamically batched when it's drawn on your screen, but if it's drawing like shadows or something, it won't be.
Slightly more performant.
What was that?
Slightly more performant.
Slightly, but not fully, yes.
Yeah. And do I have to do anything to make it dynamic, or is that like just handled by Unity if it's supported in Mono?
If it is not set to static, like batching static, then it should be automatically dynamic as long as it's under that 300 vertex limit.
Right. Okay. So not something we can't control either way, unless you're doing a thing separate from Mono. Okay, cool.
One thing to mention with that, with both of those, is with batching, you can, what Unity will do is, if you have Occlusion Calling enabled, which again, we'll get into that, batch objects can still be individually called. So you could, instead of using batching, you could go into your editor, like Blender or whatever, and combine meshes together into one mesh. But if that mesh needs to be called, then it will be called as an entire mesh, which isn't always as desirable. So it might work well for like if you have lots of meshes in one area. Again, the docs said like if you have like a chest with drawers or something like that, that's great if you want to just combine that into one mesh in your 3D software. But if you have like a field with like a bunch of grass in individual meshes, you would want to keep those at individual meshes and let it batch them, because otherwise they'll all be called at once if you put them into a single mesh. So you'll want to keep them separate.
So you kind of want objects to be like everything in front of me is one object, but everything behind me is a different object.
Yeah, pretty much.
There's the very simplified version of that, because you don't want, if I hide that, I don't want it to hide in front of me, for example, just disappear for no reason. So designing your space,
to all be on screen.
Yeah, designing your space with that in mind is a puzzle in itself, I guess.
Yeah, if they're likely to be all on screen at the same time, you'll want to combine them manually. Otherwise, let Unity do it for you. It's just easier.
Okay. Cool.
Yeah, that's about all I got for draw calls, though.
All right.
Oh, wait, one thing to mention before you go and do, I don't know if you want to do trim sheets next, but one thing to mention is each material is its own draw call. So if you can reduce the number of materials, that's a great plus.
Let's do trim sheets. Okay, I didn't prepare this, but we can definitely work with it. So trim sheets is so we have a question: what's the best way to monitor draw calls when building? Game mode, stats window.
That would be where is it? If you go to window analysis, there's a profiler in Unity. I believe you need to, actually no, I don't think you need to have a cam. Analysis is up towards the bottom.
Gotcha. Which one?
It would be, I think the profiler is the one you want. And I believe there's a way to monitor draw calls in there.
I hate this. It's just so much stuff I don't understand. I think you do actually have to play it though, right?
You can switch to editor.
There we go.
Instead of play mode. If you want to do it in the editor. If you do it in play mode, you'll have to have a camera, I believe.
Right. Okay. So a bunch of graph stuff that says things.
Yeah, you can disable individual things on the left though, because it's a lot of them.
Yeah. So what's the most important ones that we need to worry about?
Rendering and animation, and I think the global illumination there is real time, so I don't think you have to worry about that. There's a batches count and a triangle count, so that could be important. Set pass calls, I'm not sure about that one actually. Never mind. Sorry. For draw calls, what I was thinking of is in the same menu, window analysis, there is a frame debugger. That's what I was thinking of.
Okay.
But yeah, I mean, the profiler is great. But I just the frame debugger is what I was thinking of. If you click enable on it in the top left.
Need a camera, I guess.
Oh, yeah. Wait, do you? You shouldn't. If you go back to, because it's set to editor.
Right.
Yeah.
Look at all that information.
What? That's weird. Oh, wait, no, maybe you do need a camera. Oh, that's annoying. Yeah, I mean, you can just throw a camera in your scene and move it around a little bit. But that will show you all of your draw calls and like what they actually are. So if you see like a lot of shadow draw calls, maybe you could reduce the number of objects being shadowed, or passing shadows or whatever.
Okay, so we have a camera. Yeah.
So on the right is the number of draw calls. It says 52 right next to camera.render. That is, I believe, your total number of calls. Yeah, and you can also reduce it, and I believe that will
that's fun.
actually kind of step through the draw calls. So you can see what's being drawn in a specific order.
Nothing. Okay, that's interesting.
Yep, that's all the shadow map stuff. Yeah, so that's good if you want to see the total number of draw calls. And I don't know, do you have GPU instancing enabled on the tires?
I don't know. Let's have a look. I can't.
Because I wonder if you disable that, if the draw call count goes up.
Because it's in game. Hang on. There we go. Okay. Tires. On the material, these ones. They were on. So let's what was it? 52, right?
Yep.
Okay. Give that a shot. 74. What?
Yep, there you go. So GPU instancing will reduce your draw calls.
Okay. So that's a big jump. Because that's only like 4 objects and like 8 objects because each one has a rim and material. So okay, that's interesting. Do you know what a good draw call amount is? For Mona?
I don't have a number because that varies wildly based on what your scene is doing.
Yeah. As little as possible.
Yes, that is the correct answer. As few as you can.
Yeah. Okay. Yeah, cool. I didn't even know that one. Excellent. All right. So do all the things to reduce that one number in Frame Debugger. Cool. All right. Okay. Any other points on that one? Any other questions before moving on? Right. So what I'm going to do is make a very simple. I gotta find the. So I bought some trim sheets the other day because they're cool. Pretty reasonable. Yeah. So we've got actually that normal map is not the best one. So I'm going to open a normal map. Yeah, much better. So say for example we have this fantastic box now. Now I've used this quite a lot in my hex gallery for the bounty, the first bounty, and basically what you're trying to do is create really interesting ways to save, like use this texture in every possible way that you want to the point where you just add a couple of vertices per situation, right? So say, for example, when you have loops like this, for example, this is really useful for things like... Actually, I'm going to... mark scene. That on, because I always forget. And then unwrap. So we don't want these because I'll get to them in a second. Over here. But say, for example, I can move this here. Scale that down. You would want to make sure that the top loop here lines up with the bottom here. So I could probably just... why? I think it is. Ah. Okay, I'm going to cheat. No! For example, there. And then when we show this, we have a perfectly good, very messy on the sides, sort of element there. And say, for example, you could do this with all sorts of things. So say, for example, I use example a lot. I'm going to stop doing that. So say, for example, I want to put these on the sides there. So I would mark those seams. Let's do the same. So keep them sort of in line. Mark seam. This time I'm just going to get those ones. Unwrap. And then it has, let's say that one is pretty cool. Now, you can like warp a little bit, and it doesn't, especially with this sort of design, like there's not so much issues with that sort of tweaking and moving things around as long as it looks good on the end. Unwrap this. Yeah, let's do the same thing. Now, another example would be, say, for example, you wanted to do a house. So instead of random science fiction greebles, you would have a brick section, a door section, a window frame section, and then you apply each one to equal parts of the building, and then you create. Basically, you can have a whole building with one material, just by good, smart UVs. To create really interesting sort of objects there. I had some really weird examples where I wonder if I can do it kind of quickly or not. Where I had actually theme. Now, another one I use a lot is actually bound project from view bounds. So you have the full thing there. And then just doing really weird things where I rotated. Oh, no, that's not what I want. Nope, that's what I want. That's what I want. And then you start getting some really interesting sort of effects when you go across that, for example. This is a bad example, but you can sort of get the idea where you can start like doing some interesting things with shapes going around objects purely because of the UV maps. But yes, this, as I said, is not the best example of that. Or say, for example, I do have a curved object like this, and then I can just straighten these up in the UV map for interesting effects that way as well. So, once again, bad example, but hopefully you get the idea in regards to potential of what you can do with interesting shapes using UV maps as a tool rather than the material itself. So that's kind of cool, for example. So you can make some really weird shapes. When I had hexes, I started using those a lot with just using sort of lines going around the hex, which was in fact just UV maps. So it was quite interesting how that ended up being in the end. I'll see if I can actually open an example of that. I don't know. Let's see. Do I have the object? Did I just not worry about the object at all ever? Assets? Yeah, this should work. Okay, so models. Don't have any models. Okay. Oh, that might have been too early. Okay. So many versions. I gotta get rid of some of them. Yeah. Oh, these are blends. Okay, hang on. Organization plus. Okay, let's try again. That's a bit better. Okay, so prime example of... I had so many things. I think the balconies were okay. Yeah. So this whole section, I probably could have optimized this. This is a lot before I looked into a lot of it, but this is the UV maps, for example. So some of this wasn't very important because it was too small. But a lot of these lines, for example, were just one straight element of the UV. So I don't think I actually have the materials applied. Yeah, I don't. Let's see if I can find that then. Here's, I think it was 2. Fingers crossed it's 2. It is not 2. Let's try 1. Nope, wrong one. But you get the idea. So basically, if I rotated everything that way, you would have the lines across the fences there, for example. But I forget exactly which one it was. Please, please, please. There we go. Yeah, that's it. So yeah, this is how basically I did all of the benches. The floor, for example, is just the line there. So lots of uses of trim sheets to make sure that I use one material for as much as possible and get some really interesting results with that. So it was quite useful for that. Yeah, thanks for that. Yeah, so that's trim sheets. There are definitely more tutorials on YouTube in regards to sort of more specific examples. The house, for example, I used it with a lot of tech, which saves a lot of time because you can sort of do whatever you want with tech. And when you have sort of like cylinders and objects like that, you can get a really clean result by just wrapping the straight line trim sheet around it with really good results. So there's definitely lots of ways you can optimize material use, especially with draw calls in mind, with trim sheets, and it saves a lot of time to come up with really interesting results. So trim sheets for the win. Moving on.
Okay, I guess kind of occlusion calling then. The
Okay.
big section.
Yeah.
Okay, so occlusion calling. Calling is basically where your where Unity is trying to prevent what's called overdraw, because when your scene is drawn, multiple objects are being drawn at the same time, and sometimes they're also being drawn in the same place on the screen. And what happens is if one object's drawn and then another object is drawn entirely in front of it, I guess it's better from this perspective, then you don't want to see the one in the back. You only want to see the one in the front. You don't want to draw the one in the back because that's wasted resources. So a culling is where you're going to try, or occlusion culling is where you're going to try and detect when you can not draw or cull the object in the back. So real quickly, we can actually see where overdraw is happening. If you in the scene view in the top left, you can switch your shaded view to overdraw. It's there somewhere. Yep, and that will actually show you how much overdraw there is. So you can see, for instance, all of those tires have a lot of overdraw in the middle, and you can't really optimize overdraw for vertices within a single mesh, or you can, but not with Unity by default. but you can optimize it per object. If you have two objects, one in front of it, one in front of the other, you can use the object in front to hide the object in the back. So
Quick
a couple
question.
things with it. Oh, yeah.
So you said there's a lot of overdraw with this picture. I don't know what this means.
So essentially, you see where some parts are lighter than others?
Okay. So right. So everything's sort of semi-transparent. So if it's more solid, it's being overdrawn.
Yeah, that means there's more stuff being drawn there than is potentially necessary.
Okay, so that, for example, the polygons behind there are being overdrawn.
Yeah,
That's
like
cheating.
Instance,
they just put a transparency shader on things. That's not a whole shader thing. Okay, sure.
A good example is if you look at one of the tires from behind the sign, like try and place one of the tires entirely behind the sign, or one of those signs. Yeah, all those tires don't need to be drawn, but they're going to be drawn. They're going to be put in a draw call, because they're all behind the sign, but Unity doesn't know that it shouldn't draw them. So Occlusion Calling is going to say, hey, there's an object here. We don't need to draw those. So with Occlusion Calling does come a couple things. You will get some CPU overhead because it has to determine what objects to hide, what objects to not hide. There will be a bit of a memory footprint, which we can take a look at when we actually get to baking occlusion. But generally speaking, in larger scenes, especially where not much that needs to be visible at once, it can be a very good uplift in performance. Okay, so how about let's first look at how to kind of enable objects to be occluders or occludees. So in Occlusion Culling, you have two things. You have an occluder, which is going to be hiding an object, and you have an occludee, which is going to be an object to be hidden. Now, an object can be both. You can have an object that is both occluding other objects and being occluded. So it will be called or cull other objects. The most important thing is when you allow an object to be an occluder or an occludee, it must be static. Let's see. Lost Matt.
I'm back.
Oh, there you go. Cool. The video feed's a bit delayed, so I'm not sure what's happening when. Okay, so how about let's look at occluders first. So the easiest way to set this is if you click on an object like that sign, for instance, and check the drop down next to static. Yep, right there. You can set it to an occluder or an occludee. So if you set that to an occluder, there's a couple requirements for it. It has to be static, first off. Because what happens when you do occlusion calling is you're actually baking the occlusion data into an asset that is loaded during runtime. So
would this be considered static? Now that I've clicked this one thing?
Yes, it would be, but not for everything. But I mean, a good rule of thumb when you make something static is you're making a promise to Unity that you won't move it.
Right.
So if you make something static, you should not move it because Unity is going to assume that you're not going to move it. And if you do, it can have weird effects. Like if you do occlusion calling and bake your occlusion and then move an object that was baked, you're going to see things hidden behind it or behind where it was, even if it's not there. And that goes the same for anything that's static. Let's see. So another thing is it must be opaque. If it has a transparent shader, it will not occlude things.
Right.
And it can only be a terrain object or a mesh renderer. It can't be like a skinned mesh renderer, like if you have like an animated character or something like that. One other thing, with level of detail, it will use the first level, so it will use log 0. So if you have significant differences in like what's that called? Like the silhouette of an object, between LOD modes or LOD levels, then it will only use the first one, the highest detail one. So that's something to consider when you're setting up occlusion culling. Yeah, so like for instance, even if there isn't like that small angle he was pointing out, even if there isn't a mesh there, it'll still be occluded because the LOD covers that. The first LOD covers it. Okay. Usually it's good for kind of larger objects. That'll cover a lot of stuff. Okay, that's occluders.
Would you say?
Oh, yeah.
Would you say if you just press the static, so say for example, like all these objects, all these tires, for example, if I just put that, go, go, go. I hate that. Sure, that'll do. So if I just put that on, so all of it's on, basically that's the occlusion culling sorted, right?
Essentially, yeah.
Right. So I've been doing it correctly. Yay.
Well, it's
with the other factors.
Allowing it to be and working with occlusion culling. But if you just built it right now, it will not do any occlusion culling whatsoever. There will be none.
Okay.
So that's where baking comes into play. So first, with objects that are being occluded, so occludees, that works on smaller objects that will usually be behind things. Transparent objects, that's also a good. It'll work fine on transparent objects if you're trying to occlude them because, it's just like any other object. An occludee does have to be marked as occlusion static to be baked into the occlusion data, but dynamic objects can be occluded. There is an option on mesh renderers called dynamic occlusion that will allow them to be occluded by static occludees. It's somewhere in there. Yeah, at the bottom. So static objects can be occluders. Dynamic objects can be occludees. Static objects can, of course, also be occludees. But a dynamic object cannot occlude static or dynamic objects. Okay, if you mark something as occlusion or occludee static, by the way, it also cannot move, or else it'll mess up the occlusion data that's baked.
When does it bake it?
Cool. So let's get into that. The occlusion culling window is if you go to window rendering, it's just called occlusion culling.
I've never seen this. This is new. Cool.
Yep. So this is where you actually enable occlusion culling. So if you go to the bake tab, there's some settings there. Smallest occluder is the size in meters of the smallest object that will be occluding other objects. If an object is smaller than that, it will not be occluding another object. You usually want to set that as high as you can to get the kind of occlusion that you want.
Are the defaults usually okay or not so much?
They're okay.
Okay.
You'll want to fine tune them. But generally speaking, they should be okay. Smallest hole is the smallest hole through which a camera can see in meters. So, like, if you have a hole in a wall that's really far away, then if it's smaller than that size in meters, it will cull whatever's behind it. But if you have like objects like that with small holes really up close, you may not want to have that be a very large number. So again, for both of those, you want them to be as large as possible while still getting acceptable looks, because that'll reduce the size of the baked data. Backface threshold, that's a bit of a weird, more advanced setting. The way I understand it, it's when it's baking your occlusion culling, it is looking through different areas of your meshes to see what percentage of back faces it can see from certain points. And after that threshold, so a high enough percentage, it will not include that area in the occlusion data. So the 100% threshold by default says everything is included. If you lower that down, you'll start getting some parts removed. It can help reduce the size of your occlusion data, but it can also lead to artifacts if you don't know how to use it. I've never touched it personally. I don't think there's much reason to, unless you really think you can get some performance out of that. So 100% is usually good.
99 it is.
Sounds good. Yeah, you can go ahead and just click bake in the bottom right, and it'll start baking that. So hopefully you might get some stuff. Cool. So it baked that really quickly.
Can't imagine why.
Yeah, no idea. But if you have a really large, complex scene with a lot of static objects, it might take longer. Cool. Now what you can do is you can actually visualize this. Do you have a camera in your scene still? I think you do.
Yep.
Yeah. So if you enable gizmos again, I think that's necessary.
That's new.
Yeah, there it is. So you can kind of see these larger like areas. And if you move your camera around, you can see in the scene view what parts are going to be rendered. If you have, like, if for instance, if you moved your camera behind that sign, those tires would most likely not show up. If you, you have to move the camera object.
Ah, okay.
So yeah, it's the opposite way.
Yep.
You can already see them being occluded by the frustum. So frustum calling is something else it does. If something's outside the camera frustum, so the amount of space or the stuff you see there, then it's not going to be included, which is good too. For some things, it doesn't actually look good, so you have to decide whether that's good or not.
Okay.
But yeah, so if you move it behind the sign, I wonder if it will start removing them. No, it doesn't look like it. It may be because it doesn't meet that threshold.
I don't think these are static. I don't think the thing is static actually.
So it's occluder static.
I think I dabbled with that, so that's why. I'll put all of it and then rebake it maybe.
Yeah, I think the other thing though is the size, the minimum or smallest occluder. Maybe set that to like 0.5 for the smallest occluder just to test.
Bake. Okay.
Yeah. Let's see what that does. Oh, no, they're still there.
Interesting.
You can see how the smallest occluder kind of affects it though.
Yeah.
Ooh, is 0.5 still too small? Ooh, I think that's a radius then. Maybe do like 0.1 then, jeez. You can see how much extra data it adds though when you set it to a smaller number. So usually it's good. It'd be better if you have like a big building occluding objects.
That takes a while too, or longer. Anyway.
Yeah, you can see it. But now you should not see those tires, hopefully. Or you still see them. Okay.
Finished yet? But yes, like.
Oh, okay.
A lot more.
Yeah, so that's why you want to keep both of those numbers as big as you can.
Yeah. Okay. Well, still there. But yeah, it could be a couple of things, but yeah, I think the idea is definitely there.
Yeah, it works much better with larger objects.
Yeah, for sure. Okay. So what were the conditions again, just to cover that? So it had to be static. If all of them are on, it's static. Mesh renderer, dynamic occlusion is optional, but you can do that.
It has to be opaque. Occluders have to be opaque.
Has to be opaque. So let's click on the sign. Any other factors. So opaque, standard. Opaque, standard. Any other factors? Maybe?
No, I don't think so.
Would width be a thing? So does it have to have a certain depth before it triggers the occlusion? Because these signs are pretty thin, for example.
You know what? Maybe just make a massive cube. Let's just try that.
There we go. Let's bump that up to 0.5 because that was way too slow. Okay.
Yeah, if that doesn't work, just make like a massive 10 by 10 cube and see
if it works.
If it hides. Oh, there you go.
Yeah. So depth of objects makes a difference.
One thing you can also notice is the shadows are still there.
Yeah, those are baked. Baked light.
Oh, is that baked?
Yeah.
Is the light baked here?
Actually, no. I don't think so.
The reason they're still visible, like the real-time shadows, is because Occlusion Calling does not affect what your lights can see. So it only affects what your camera is drawing. So if you're worried about objects that aren't visible not affecting your shadow maps, you don't have to worry about that because Unity will still draw those objects in the shadow maps. What it also does, though, with shadow maps, which is a nice automatic optimization, is it limits the frustum of the shadow, of the light camera, to just what is visible in your games camera. So it will not actually render shadows outside of that range. Now that does include the scene camera, so you can still see shadows here because of your scene camera.
That's cool.
Yeah, you can kind of see it disappearing over there.
Okay, interesting.
Yeah. Now there is one other thing with that is if you have multiple scenes, usually what you do, if you have just one scene at once, is you would bake your occlusion for that one scene. But if you have multiple scenes being used at the same time, like in Mona we do, what you actually would want to do is if you load, I believe the space scene is loaded first. So you would want to, for instance, unload all your scenes and then load just your space scene, and then load the other two scenes after that. Just drag them into the hierarchy. You can bake all three of the scenes at once, and what'll happen is when they're loaded in runtime, it will use the same settings. If it detects that those three scenes loaded in the correct order are using the same settings, it'll just load the data. It'll just load the data once and use it for all three scenes. If you don't do that, if you render or bake it per scene, you'll be loading 3 times as much occlusion data, or 3 separate sets of occlusion data as opposed to just one. So with multiple scenes, it's good to bake all of them at once.
How do you make sure that they the 3 scenes should be like they are now, and when you press bake, it'll do it all?
Yeah. So there is something to be said about scene loading. I don't know for sure, but I'm pretty sure Mona loads the space scene first, and then the other 2 scenes. If not, they should do that way, because space usually has the most meshes. So if it does it that way, where it loads the space scene first, and then the other 2 scenes after that, as long as you do the same thing, you make the space scene your primary scene by loading it first, and then add in the other 2 scenes, and then bake it. Should bake it for all of them at the same time.
Okay, so as long as all 3 scenes are open, when you press bake, it'll do that one time, and that'll be fine.
Mm-hmm.
Right. Okay.
Karuna mentioned in chat, smallest occluder creating more data. That is actually not CPU overhead. So the CPU overhead is is like a constant for your occlusion data. It would be a memory footprint. The more those tiny areas that you have, the more data you're storing, and the more you have to load into memory. Actually, go back to the Occlusion tab if you can, real quick. And at the bottom, it should say how much memory it takes up.
The bake. There we go.
Yeah.
41K.
Yep.
That's a 0.5.
So this is a very small scene.
Yeah, very small scene.
Yeah.
0.5. So let's do a 0.1 and see how big that gets, I guess.
Yeah, you can get multiple megabytes, so you want to be careful with that. So, yeah, with Occlusion Calling, there's a small CPU overhead, but you're more worried about how much memory it takes up. So yeah, optimizing these settings for your scene is going to be a good step in ensuring that that is done appropriately.
253 on that. So yeah.
Yep. So that definitely increased.
Cool.
Okay. There's just two more things with Occlusion Calling. The first is Occlusion Areas. So you can just add an Occlusion Area component to just like an empty game object. And it'll let you define how much space it takes up. And what an Occlusion Area is essentially it is kind of it is defining where a camera is most likely to be. So for instance, if you have multiple rooms, it would be great to put one of these in each room. And what happens is it will calculate higher precision occlusion data in each of those areas, and anything outside will use lower precision data, which takes up, of course, less memory, and there is actually less CPU overhead from that. And the areas inside will be calculated at a higher precision. And then when you go outside of an area, when your camera goes outside of that area, it will lost my train of thought. Oh, when your camera goes outside of an occlusion area, the objects inside, or the occlusion data inside that area, will be used or calculated at a lower precision. So using occlusion areas can help improve your occlusion bake times, and it can also help improve your performance while using occlusion culling in your game.
Okay. So kind of like it improves when you're close, and like it's more accurate when you're looking at it and less accurate when you're not.
It's not necessarily where you're looking, it's where your camera is positioned. Right. So your camera has to be inside of an occlusion area for it to take effect. But yeah, it's the same kind of idea.
Okay, so like when I'm in this area, pay more attention to the things in this box.
Yes, exactly.
Right.
So that's why it's where your camera is more likely to be.
Right.
One thing to mention with it is you need to have that checkbox, is view volume enabled, otherwise it won't work. Right. Because by default, if you don't have any of these, Unity will create one massive view volume for your entire scene and render everything or bake everything at a higher precision and load it all at a higher precision. So this can help optimize.
Okay.
One last thing is Occlusion Portals. Occlusion Portals will let you kind of create an occluder that isn't necessarily tied to a mesh renderer. So if you add a portal to an object, it can block things that are behind it without necessarily needing a mesh, and you can define how much area it takes up. And that's good for things like if you have like an animated doorway, you could animate whether this portal is open or not, and have that like when you open the door, you can disable the portal and you'll let you see everything, but when you close the door, you could re-enable that portal and it would cull everything behind it. So you could use it to kind of represent the occlusion of objects behind dynamic objects. Not in a super precise way, but in a little bit better than it would be otherwise.
So you would sort of show or hide this with animation on a door, perhaps. So yeah, this can be animated. This can be animated, basically.
Mm-hmm.
Right.
And yeah, it's just an open option on the portal.
Right. Okay. That's cool.
Yep. So yeah, that was a big section. I think that's about all I got for occlusion calling, though.
Excellent. Yeah, I haven't done that nearly enough. So that's super useful for me because I'll be using that. Should use that a lot more.
Yeah, me too. Upcoming projects.
It's no fun though. Nobody wants to do occlusion. It's just like, sure, I'll do it if I have to. It's kind of like unwrapping. No one likes unwrapping.
Oh gosh, I hate unwrapping.
All right, cool. So that's occlusion. Next one, let's jump into some prefabs. Prefabs are, it's a bit of everything. It's kind of organization, makes things easier for you to deal with many objects of the same thing. It also allows you to do some interesting stuff with... So say for example, we had... we wouldn't want sort of 4 wheel, like let's say flowers. Imagine these are flowers or rocks. They're tire rocks. You wouldn't want 4 different rocks when, say, for example, you could have 4 same rocks that kind of look different when they look upside down, for example. So here we have basically one draw call, but we have 4 very different objects, for example. So that creates the variation, but it looks but it has the same amount, and you can probably batch this as well, right? So even though they're the same objects and just scaled. So yeah, this would technically be a very performant, and I could make this quite large and quite a lot, and that would be still one draw call, I guess. So you have a whole
below 64,000 vertices.
64,000 vertices. There we go. So with that, for example, we would want to create a prefab, which is done here. Now, let's say we import an object. So I'm going to make a new prefab. So say, for example, we have our imported object, which is this little box with the line on top. So we've got that. I'm going to apply the materials, for example, and then, where's that? I'm going to drag this into, and I usually put it in a prefabs folder. For example. Now, you get the choice of either original prefab or a prefab variant. We'll get to that in a sec. We want an original prefab. And then we have this. So when I double click on this, we can modify this in isolation, for example. So when I click on each object, for example, so I'd have to set the materials and all the rest of it correctly. But I can tweak the mesh renderer and stuff like that, tweak the material if I wanted to, all those sorts of things. Now, the benefits of this is every time I update this particular object, so it's this one here, so we'll put it separate. There's a good LOD example. So every time I modify this, so let's put a new material on it. Need more stuff so I can do more things.
Is a default one?
Yeah, I'm just trying to find that. Floor, this one. So let's say we have this as an example. Now that has happened to this particular object, but it has not happened to the prefab. So if I copy this prefab, no, it wasn't that one. This one. It keeps the original. But if I, for example, go override and then apply all, this will update. So if I had 1,000 rocks, for example, and then I decide, you know what, I hate this shader, I hate this material, I want to change any of these sort of things, I can do it in the scene and then apply that to the prefab, and that will update all of them. You don't have to do it manually. The other option is if I edit it either there's a few ways to do it. So if I click on this arrow, this will go into the prefab itself in the scene. And then I can put an object on it, and then it will update everything there. The other option is I can right mouse click, go to prefab, open asset in context, as in the scene, or open asset in isolation. which will go here. And then I can update the information there. And you don't have to do the override, for example. It will just update all of the objects. So say, for example, we have these 4 here, which is based on this tire here. So I'm going to double click that. I'm going to put the stone texture on it. And when I go back, those 3 are changed because I didn't modify that. But this one, I changed the material separately. So if you modify it manually, that will override the base prefab, I believe, if that's correct. So yeah, only change it manually if, and this is a prime example there, if you want to. Now notice how this one I've changed, and when I set it to the prefab, the other ones that use the same prefab also change. So this case, you might just want to leave them separate and then don't change the upgrade. So you just change the material. But as soon as you change or apply the override, the scale will also change. So that's a bit of the finicky part with prefabs and scale, and making sure that you copy the things you want to everything, but not all of the things you want to. If you want to, you could create a prefab variant, for example. So I'm going to grab that, the small one. I'm going to put this in the prefabs here, and a prefab variant. Now this has a little shaded thing on the front here. So when I copy and paste this one, oops. If I change, what's a good example? So I'm going to, yeah, that's a variant. So I'm going to scale this one up. Oh, that's an LOD thing. Cool. So if I change this one, apply, that will go to the variants. Why didn't that one change? Fine. Yeah. Okay. I don't know why that one didn't change. Any ideas there?
The scale is overridden.
Right.
I think. Is that what it is?
Okay. Yeah, I don't use variants for this very reason. Because it does get complicated on which is the original, which one's the variant. But with a bit of playing around, I'm sure you could understand the process a little bit better than I do. That said, the theory is anything from the prefab parent, like the original, will carry down to the variants, and any of the variants will carry across to similar variants. So generally speaking, I will only use prefab originals, and then scale them in the scene, and just make sure that I don't apply the things I don't want them to, for example. So yeah, a bit of a mix between sort of custom objects and prefabs, and just making sure I use that, utilize that in ways that benefit me and make sense. But yes, very powerful for large amounts of objects in one scene that are very similar, but you want them to be a little bit different, but then you want to update them sort of en masse, basically. Are there any other benefits to prefabs, like performance-wise or anything? Like, is instancing part of it?
Yeah, memory. Memory is a big thing. And disk space. So with prefabs, what happens is if you just like add game objects into your scene, that is just adding more data into it, essentially. Like if you're saying I want this model here, this model here, this model here with this material, whatever, so on and so forth, your scene has to carry references to each of those objects, and each of those references have to reference back to different materials and meshes that it uses, and all of that takes up more memory and disk space. Whereas using a prefab, it just has to say, I want this prefab, and then all of the external references are stored into that single kind of prefab reference. So all the prefabs, they all use the same mesh, so you don't have to say this game object uses this mesh and this uses the same mesh, but they're two different objects. You say they're the same prefab, they both use the same mesh, it'll just reference them as the same prefab. So you'll save on memory because it won't have to load all those individual references, and it also won't have to save them in the scene file. It can just say it's this prefab, and it'll know what else to reference from the prefab definition. Now, depending on how many prefabs you have, that the performance is a bit negligible there. But it is absolutely great for optimization. And if you do have something, like Matt mentioned, a ton of rocks, for instance, in a field, or grass meshes placed everywhere, or trees, or something like that, imagine having 1,000 trees that are individual game objects as opposed to having 1,000 prefabs of one tree. It would be significantly more optimized. And also because they're prefabs, there are some more optimizations that it can do with the draw calls and batching as well, as opposed to having individual game objects. So those are just some of the more performance benefits you'll get out of it.
Oh, cool. So that's prefabs. I use them a lot with what did I use them a lot? The rocks. I had a garden that had rocks, for example. I used like way too many non-prefab rocks. I should have once again scaled, moved, rotated. It's amazing how different a rock can look from different perspectives and different scale. So yeah. And there's a lot of that sort of stuff in a lot of spaces, for example, especially with natural things. So definitely recommend using prefabs to clean up the process, even if it's just to save time. Because yeah, you will always say, you know what, I don't like that rock like texture, and changing 1,000 manually is not fun. So yeah. You can also, like, say for example, if I modified any of these elements on this one object and it's not a prefab, I would have to do that on every single one. So maybe because the object is smaller, I want to turn off the it's a small object, so putting it in the light map is just not worth it. So I want it to cast shadows, but I don't want it to be light mapped because it'll just be too small in the light map information. So I can use the light probes for lighting of that object and just make sure that that's how that applies. Now, doing that per object, not fun. So use prefabs to save thousands of hours of time when creating things that are everywhere and very, like, extremely similar, for example. Now, of course, unique items, you wouldn't use that. You can if you want to, but you don't need to. But yeah, when you're using a lot of the similar or same object, then prefabs are highly recommended. You don't have to put it into a prefabs folder. As long as you drag it into the project somewhere and it comes with a blue box like this, it is a prefab or a variant with the option there. So you could put it wherever you want. I just put it in prefabs so I understand these are models, these are prefabs. Once again, just proper file organization so you know what you're doing quickly and easily. I will also, personal choice, I will usually put, say for example, if it was a prefab, I would actually put a P underscore in front, just so I can start understanding what's what. Once you put it in the space, you can name it whatever you want, for example. So I would still probably keep the P and then just put numbers at the end like it usually does. That way I know these are going to change when I update it. These are not, things like that. Same with reactor. I will put an R on the objects just to know this is where the reactor script is, for example. So yeah, that's my approach. Do as you will. So yeah, that's prefabs. Next, how you going for time? You good for time?
Yep. We still got half an hour-ish.
Cool. All right. Next, light mapping, maybe.
Yeah, I think that's the only thing really left on the list.
Okay. Light mapping it is.
Okay. Shall I jump into that one then?
Yes.
Okay. So, yeah, light mapping. We all love it. We all hate it. I personally love it. So, I love it when it works. Optimizing light map is uh, not so important for performance, but more important for saving like disk space and memory. Because obviously the more light maps you have and the higher resolution they are, the more space they take up and the more that you have to load into memory. So some of the easiest ways to optimize your light maps are just like right in the settings. You can lower the resolution. You can compress them. There's a setting to compress their light maps right in the lighting settings. Oh yeah, you have to generate. There you go.
I'm gonna bump all of these down because the default are way too high.
Yeah, and then you
how
can.
do I usually do it?
Like bakery.
A quarter, yeah,
Bakery.
a quarter for all of those. Which one? Directional should be non-directional. 2048 is my usual, although that can be up and down. Ambient inclusion because it always looks pretty. I think that's about it for my first pass. Progressive GPU is faster, but doesn't look as good. Progressive CPU is slower, but looks better, generally, I find.
Does it actually have a difference in quality?
Yeah, definitely.
Oh, God,
I hate progressive. It's very muddy, is the best word I can use for it.
The GPU one?
Yeah. But it's much faster, like significantly faster.
I didn't realize there was a difference in actual quality. I thought it was just a rendering method. Okay.
Yeah, it also depends on like your settings and how you set it up and what kind of space you have as well. So there's a lot of factors involved with that. I don't think I've set anything to static, have I?
The tires, I think, are static.
Yeah.
I think that's about it.
Okay. Oh no, full static.
Actually,
I have
yeah,
and I have no lights. There are no lights that are baking, so that's going to be.
That would be it.
Let's bake that for one, and let's add a couple of other random lights, I guess. Point light.
Yeah, to mention with the static stuff, it's one thing that is great to optimize your light maps is to just actually reduce the number of objects you're baking, because the more objects you're baking, the more objects you have to pack into light maps, and it'll create more if it needs to. So if you can just straight up not bake some objects and just use light probes for them, that's great, because that'll reduce the space or have them not take up any space in your light maps.
Yeah. So things like this, for example, which is really small and doesn't really cast a shadow, like it does when it's on the up. But if this was like a rock on the ground, I would definitely turn off the static on that one. But these ones are bigger, so I would probably keep them. So even if they're on the ground, for example, they would throw a big enough shadow to be worth adding to the static light map. But small ones like this, maybe not. So you've definitely got that sort of thing as well. So yeah.
The other big thing is for individual objects on the mesh renderers, you can adjust the scale in light map, so how much space they take up in the light map itself. You have something really far away. That really helps.
Where is that? Mesh renderer, right? Scale in light map here.
Yep.
So if this is either very important, you can bump that up, or if it's not very important, you can bump it down, depending. I think it's like if it's 2, it's double the size. Is that how it works? Yeah.
Yeah, it's very linear.
Yeah. Okay.
Yeah, that option alone has taken me from 72 light maps down to 16 before. So, that is for me a very important option. And actually, a good way to test that is the grid view. I forget where's the. I think it's on the. No. In the inspector. I think on the mesh renderer. Is there? Oh, I forget where it is. I just thought of it again, so let me look it up.
We didn't generate light maps. Hang on. So we're gonna do that. actually. Where is it?
Yeah, I'm looking for the grid view where you can see like the grid over everything.
Okay. The other thing you need to do, and make sure you do, is generate lightmap UVs on your objects. If you're using Unity to generate the secondary, so you have a UV map that your texture is on, and then you have a second UV map that the light map is on. If this is not on, it will do fantastic things like this. Where is it? Yeah, one of them anyway. So this is a prime example of very bad light maps. But if you go to the object itself, the model, not the prefab or anything like that, go to the model tab, go down to generate light map UVs, and then apply. You will have to rebake, so make sure all of these are sort of done. And then, was it going to set anything else? Oh, let's go to CPU. Right.
Get the wrong documentation.
Yeah. Still going? Still going. It'll take a little bit. Chunking through it. No, if the audio goes broken at all. Go, go, go. There we go. So as you'll note, this small one doesn't have a shadow because it wasn't set to static, but these ones do. If you move them, that's what happens. And as you can see, the quality, well, you can't see with the texture, but when it wasn't there, there we go. LODs are very useful for seeing what the light map is like if you just put a different texture on the different LOD. So you can see it fuzzy, but that's mostly because these are quite small at the moment. And that's really high as well. So light map resolution. So to start, it goes much faster. And this is a very simple scene, so the quality of things is going to be very low. But whether you have more polygons and you have better bake maps, so as you can see, you don't get that weird, like shard version of the tire. This is all cleaned up now. Now, a lot of people, or many people, are starting to use bakery, so we could get that in a second as well. But here is an example of, because the floor is one polygon, basically, the maximum size that it will create a light map for is 2048, which is not great. So make sure your floors are broken up enough if you're light mapping to be able to break them up over different light maps if you want them. Each light map is quite large in file size. So it has, like, once you go to bike light maps, it has 3 non-directional light maps, 128, 2048, and 256, for example. So it has that approach for getting information if you need it. So yeah, there's that.
I can't find it.
What are you looking for?
The thing where you can see the like it applies a grid texture onto every UV light map UV object.
Right.
So you can see how big it is. Maybe that's only a bakery thing, because I know how to enable it in bakery.
Right. Maybe.
I don't know. But like, basically, if you can apply a checker texture to every model and use the light map UVs, is essentially what it does. You would adjust it so you kind of put your camera where your camera would be in your scene, and adjust all the scale of every object in the light map so that the grid tiles look the same at every distance, like their size in pixels on your screen. So that farther away ones will be take up less of the light map, and closer objects will take up more of the light map. And it's just a good rule of thumb to adjust the scale and light map so that everything kind of looks the same and has the same amount of detail at its given distance.
Yes,
that's what I was looking for. I don't know if it's a thing you can do without bakery. Then I don't know.
So yeah, definitely play with these. Once again, important things should get more focus, or just turn everything else down. For example, probably be the approach I would use. But of course, if you had a hero object, you could push that up in comparison to everything else. For example, what other things do I use? So with Unity Light Mapper, yeah, I will. These will change the direct samples, indirect samples, environment samples affect time. So saving time as a resource. Light map resolution. This one is the one that changes how many light maps you'll get. So basically, this will look at how a unit in Unity is 1 meter, basically. So how many, texture pixels, I think it's called, a texel. So how many texture pixels per meter. So if you have 40, you're basically double the resolution that this is now. So of course that would double the amount of textures that the bake would use. Now in a complex scene, that plays a huge part. In a scene like this, it doesn't make much difference at all. So yeah. And the other thing I also recommend is, say for example, this isn't too bad, but like I have played with the light map settings to the decimal point to make sure that the bake doesn't bleed into a new map, for example. So I would probably try to fill up this section as much as possible just to make sure I get the maximum use out of the materials that I have. So I think in my first build, the hex gallery was like 25.31 or something like that, which is ridiculous. But I just wanted to make sure that I'm using the light maps as much as possible before moving on to a new light map. So that took a couple of bakes, is like plus 0.1, plus 0.1. But yeah, that made sure that I was using those as much as possible before moving on to a fourth light map, for example. So yeah. Did we want to give bakery a shot? Is there anything else on Unity probes?
Let me see.
Lighting mode. What do you know the difference between lighting modes? Because usually I've used baked indirect. Do you know what they do?
Yes. So, this is important if you have real time and baked shadows. For instance, if you set a directional light to mixed rather than baked, you can render both baked shadows from it as well as real time shadows. So if you use the lighting mode, what is the first lighting mode? It's not full lighting. That's in bakery.
Baked indirect, subtractive, shadow mask.
Yeah, baked indirect. So baked indirect is where it will only bake indirect light, and all the direct light, so shadows basically, will be real time, and all the indirect light will be baked. Subtractive is usually used for like mobile games. Essentially, it's a really basic way of combining real time and baked light, where it'll bake shadows from static objects, and then you kind of like choose a color that kind of estimates the color of all the shadows that are baked, and then it will essentially subtract the real-time shadows from the baked light map to try and get it to mix with the baked shadows as well as possible. And if you do it right, it can look okay, but it's usually kind of an optimization technique used for mobile games where it's not as visible. And it's really annoying to get right. I wouldn't recommend using it in Mona.
Which one was that? Subtractive?
Yeah, subtractive.
Right.
In Mona, I would recommend always using shadow mask. So shadow mask, what that does is it bakes indirect lighting and shadows separately. And then what it does is it'll apply the baked lighting to the scene only in areas that are shadowed. So it'll actually combine the baked shadows which is at that point just a grayscale texture, with your real-time shadows. And then that will kind of mask where to draw the indirect light. It'll only draw the indirect light in the shadowed areas. So it is a much higher quality way of mixing your baked and your real-time shadows. Now, there's two modes for it. There's distant shadow mask and just shadow masks. Mona actually at this point, only has distant shadow masks. So what, and that's in the project setting, so that's not something that you can change, here at least. But essentially what that does, if you enable shadow mask, is it will actually blend. So for stuff that's close to you within the shadow render distance, it'll do only real-time shadows. And then anything outside of that, it'll replace them with the baked shadows. So if you're having annoying issues where your shadows are only going up to a certain point and then they're disappearing because they're real time, the shadow mask method with baked shadows can replace those real-time shadows with baked shadows as they get farther away. So you can still see the shadows from baked objects even if they're outside the shadow casting range.
Right.
So that's what distant shadow mask is for.
Okay.
I do really wish that Mona had the option to allow normal shadow masks, because that would like improve the quality of certain things significantly, because then you could mix your real-time shadows like right in front of you with your baked shadows, which tend to be higher quality if you're using something like Bakery. But hopefully we'll see something like that happen in the future. But yeah, that's kind of the difference between those lighting modes. Bakery has like 6 though, so it gets a bit more complicated there.
All right.
With the lighting modes.
Bakery.
One other question: do you ever go back and set your directional node back to directional at the end?
No.
I would recommend trying it.
I think I read somewhere, and this was a long time ago, but yeah, I don't know. I read a thing and it said non-directional. It might not have even been that, so I could have it very wrong actually. I've always used non-directional, but I don't know what the difference between those two are.
Directional light maps are for specular lighting. What they do is they encode the direction from which light is coming, the average direction, into the light map itself.
Right.
So that you can actually get some basic specular lighting from baked lights.
Right.
So you can actually see like reflections of baked lights off of baked objects from the baked lighting data.
Right.
So it's great for like emissives and things like that.
Right. So is there any reason to use non-directional?
It depends. I do believe that directional light maps increase your light map usage. So you really have to consider if it's worth it, if it really adds some quality. Like you have like some like a lot of emissive meshes, it might be good to consider using directional, because then all of those emissive meshes can provide specular light. But if you mostly use like baked lights in your scene, like actual light sources, then it might not be as worth it, because you might be able to do some of that real time.
Right.
So it just depends on whether you think it's worth it for your scene, because encoding lighting data will give you some GPU overhead and some memory and disk usage as well, because it'll have to create extra data for the light maps.
Okay, cool. Alrighty, I have Bakery up. So my settings, and feel free to jump around because it sounds like you've played with it as well. I usually use experimental.
Mm-hmm.
I use baked normal maps. I go Atlas everything. Yes. I am recommended to use Optics 5 for some reason, not 7. I don't know why.
I would recommend using Open Image Denoise.
Okay.
It is higher quality. It is slower though. It runs on your CPU, whereas Optics runs on your GPU. I think Optics 5 is for compatibility. Optics 7 is better supported by more modern GPUs, so it might not work on older ones, I think.
I have a 2070 RTX, so I'm gonna try that.
Oh yeah.
I'll do hole filling because that is super good for packing UVs a lot better, and turn that down to 2048. I will open up the ambient occlusion, make that 1. RTX mode because I have one, and that's it. Any other settings that you recommend?
Depending on your graphics card, I do sometimes enable auto for the GI-VRAM optimization.
Where's that one?
It's below the RTX mode, or a little bit below the RTX mode. It's a drop down. And it's set to force off by default.
Okay.
Sometimes I'll enable auto if you don't have much VRAM.
Right.
But you're probably fine. 8 gigs. I don't think you'll have a problem.
Should be fine.
The other thing is sometimes the denoise fix bright edges option towards the top can be useful if you are getting bright edges. It's probably good to test without it first because it can reduce detail sometimes.
Fair bit of time. Okay.
Mm-hmm.
That's cool. And then I will go render. Then it will show this. Usually I'll go through it again. I don't know why, because I set it up every time, but yeah.
One thing to mention, if you do go through that, and you apply the settings it recommends, it will reset all the other settings.
Yeah.
So I think you will have to go back and set them all over again.
Yep. That's cool.
So there is something in the context menu for bakery, I think.
Yeah, so Optic 5.
That'll let you do that without having to do all the settings again.
Okay. No, whole filling's still on. Interesting.
Oh, weird. It didn't. Oh, actually, no. What I've had happen is I'll do that, I'll run through it, and then I'll render it. And then it'll reset all my settings and render with the reset settings.
I have had situations where bakery will, like, every time I render or as soon as I hit render, it will reset everything. It's really annoying. I think the last time I fixed it, I just shut down Unity, booted it up again, and it was okay. So if this doesn't save, and I think it saves when you save, then yeah, that's the only way I can suggest getting out of that. So let's give a quick... we need bakery lights.
Yeah.
We don't actually have any. So I usually use the Unity lights as a guide. I do have the GPU viewport thing, but it seems pretty buggy, and I haven't really had much luck with it. So I will use the Unity lights as a guide, and then I will add a bakery light. And then you can use these to match the light mapped, which is bakery, to real-time, which is the Unity. So there we got that. So if I change this, I would hit... so let's make that, say, 0.5. That will come up again. But if I do 0.75, I can do that. And that's all you need to do with bakery to make it a bakery light. Point lights are basically the same. So this is a bakery point light. Match light mapped to that. I have other workshops and tutorials in regards to like how setting up bakery. The only other weird one is Spotlight. Spotlight is bakery point light. You add a cookie, for example, and then you drag and drop. There is a texture they recommend, but you could make it whatever you want. They should make it by default, but they don't. I think it's just in the root here somewhere. Where is it? Unity spot texture. There we go. So that will create the equivalent of a spotlight. So I would put this on a Unity spotlight rather than a point light, and that would be that. Set all the Unity lights to baked, because otherwise they will be real time, and you don't want that. And then that's basically it. So render, save.
Feeling doubtful that this might actually bake in a reasonable amount of time.
I don't know why it's taking so long.
Whenever I see that on post process model,
Yeah.
That is the unwrapper, the X Atlas
there we go.
unwrapper, taking forever. Oh, it finished? Oh, good. Yeah, no, if you have like a massive model and you have the unwrapper set to X Atlas, it can take upwards of 10, 15 minutes for that single step.
Yeah.
Oh, I hate it. And then baking takes like 30 seconds. It's like, come on. But it's a great unwrapper.
Yeah, it's fantastic. I'm assuming the audio is all messed up on the stream. Sorry, people.
Actually, it's not yet.
Oh, really? Okay.
Yeah.
All right, I'll just keep chatting then. So yeah, the
Yeah.
the unwrapping of Bakery is so much better than Unity Lightmapper. Part of it's the hole fill, so it will like put things inside things. It's just much better at that. So, and anything that saves light map space is a godsend. So I'm hoping, yeah. So this goes back to 2, for example. So you'll have your main one, and then you have everything else in 1. And usually the quality is a lot better as well. So it kind of, yeah, that polygon is just way too big. We have to, I think we have to change the what do you call it, the default scene again. So yeah, as you can see, it's just much better, much cleaner at that. And then of course you would adjust all of these settings. So for example, texels per unit would go up or down depending on the quality that you can afford with the file size that you have, and stuff like that.
The one thing I was trying to get earlier, in the bakery settings, there's the checker preview right above global illumination. That's what I was talking about. That's what I was trying to find.
Where is that?
It's right above global illumination.
As in on the bakery thing?
Like yeah, in bakery. It's like a drop down. It's always hard to spot. Like, you know where you set ambient occlusion?
Yeah.
It's a little bit above that. So
check a preview. There we go.
yeah, it's always the hardest thing to find.
There we go.
But if you enable that, you'll see a checker, and that matches your light map UVs. So if you can put your camera kind of where your player would be most of the time, and then look at everything, you can look at individual objects and adjust their scale in the light map, and you can actually see it change. So, it only works in scene view, unfortunately. So you have to kind of put your scene view camera where your player would be. So yeah, it might not be the easiest thing to do in the ortho view, but yeah, it lets you adjust the size of the light map
in here,
or the scale stuff.
So where would I do that? On the
yeah, the mesh renderer, just the scale and light map option,
right?
And you can see how it affects it.
Are you sure?
You'll have to refresh the checker in the bakery window. Like right under the checker thing in the bakery window, there's a refresh. Refresh checker. Yeah.
Right. Gotcha.
Yep.
Okay.
And you can see now it's massive.
Okay, that's cool.
Mm-hmm. Yeah, so I use that a lot.
Right. Got some precision bacon there. Okay, cool.
Good now.
All right. Now, of course, well, and this is the other thing as well. So when you have a complicated texture, you can get away with much lower quality bakes. But if you have a plain texture, then it gets pretty obvious, especially with like seams and all that sort of stuff. And this also applies with reflection probes, for example. So if you have a detailed texture object, or your reflection smoothness and metallic is like less than like 7.7%, 0.6, you can get away with really low reflection probes, for example. So if we have an example here, so that has an example there. That's at 128. But if like nothing is shiny, and in this scene kind of nothing is, then we definitely do not need 128. We could probably get by with a 32, for example, and the quality would be fine. But when you're looking at, say, highly reflective like glass or like statue of gold, for example, then around that object, you would make sure that the reflection probe is higher. Once again, every iteration upwards is times 4 the file size. So you definitely want to keep these as small as possible. But it allows you to create those environments to create the highest quality that it needs, not what you want. I pretty much never need 2048 as a reflection probe. Like unless you had a mirror, for example, and even then, probably not. I've basically never needed more than 1048, and that's because I had like very highly reflective floor, for example, and or water, for example, and because that was animated, that would slow things down a lot, I think. So yeah, but if you notice the difference here, it's actually quite minimal. Like that, can't even tell. So yes, make sure that your reflection probes are as small as possible. Go down until you sort of see a scene, not so much on the probe in the inspector, but in the scene. Find the most reflective thing in the scene that reflection probe is used, and then go down and see where the quality of that reflection probe actually makes a difference. And yeah, keep it at the lowest level possible. That will save a lot of file size.
Oh, one thing to mention with that real quick is there's a use occlusion culling option on that, on the reflection probes. So you can actually disable the use of occlusion culling on a reflection probe in case you're losing detail on things like portals, for instance. Like if you bake your reflection probe and there's a door that is open, you want to make sure you disable a portal or disable that use occlusion culling. I would recommend you disabling the option on the reflection probe itself. But that does not affect the performance in game. That just affects what it shows when you call it.
Oh, this one?
Yeah, that's the checkbox. So that'll just the calling mask is also helpful because you can have it reflect only certain objects. I've used that to isolate like just lights. Like if I want to reflect just lights on a window, I had to do that once.
Okay. And that works in mono. You've noticed that?
Yeah. Yep. It actually worked really well. Like I got like I don't know if anyone saw like that garage I was working on, but I had like the 3 window panes and I had 3 rows of lights. And I had a reflection probe in front of each window with box projection looking at just the lights, and it worked out really well because I could see very clearly the reflection of all the lights in the window, and it looked really nice.
Okay.
When I actually got it working properly. So that was the calling mask I was using there.
Yeah.
But again, that doesn't affect performance in game. Yeah.
Yeah. Anything that every step, and some of them are very small, but some of them, like when they add up, like you can, like file size is definitely, especially because we have that file size limit. And yeah, so trying to put all of these together in one scene will make a huge difference in regards to performance, and quality as well, and frame rate. And as noted in VR, frame rate is everything. So once we get VR involved, that will complicate a lot of this. And some spaces will work on desktop perfectly fine, but will not work in VR. So we're figuring out how we're going to go about that. And just making sure, because people can get nauseous if the frame rate isn't high enough in VR. So using all these tools to make it as performant as you can while looking as good as you want is that fine balance between a good experience and a bad one generally, but 10 times more in VR. So that'll be very interesting when that comes up. I think that's a perfect time. 2 hours on the dot.
Yeah.
Anything else you would like to add to wrap up as a summary?
I think that's all I got.
Okay.
I think we went through quite a bit. I'm glad we got through everything though.
Yeah, there's definitely a lot of things we can work with. So it's just kind of like keeping on top of all of it. And like there's different approaches. Like some people would probably do this like every step of the way. Some people would block out and then build the space and then cut it down. I'm not sure there is one way that's better over the other. Pros and cons to each. But I think having these in mind at all times is the key thing. It's like, okay, how can I design my space to be better at occluding, for example, so I don't have everything open all the time. I can sort of put some key walls around or windows and things like that. And just applying all of these sort of things will create a much better space. And yeah, treat it like a puzzle. It's like, okay, how performant can you get it in the time that you want to create it in? So deadlines just add a whole new layer. So there's that too. All right. Hopefully everyone's learned a thing or two. I certainly have. So that's good. If anything, I've learned a lot. But yes, hopefully everyone else has learned some very useful tools to making their space smaller and more performant. And thanks for joining. Have a nice day. Bye. Let me press this button.